these. So with the first question, right, or the first thing that they're mentioning, which is the description. So the funny thing with applications of calculus is that as long as you understand your description, you're okay. But normally the description is one of those things that are usually misunderstood, because most of the time it's like, what are they even asking? What do they want? What do I have? So the other thing also is you want to always think of these questions in a literal sense. You see? So if they mention something about a real life scenario, just think of it like that also, be realistic about the question. So anyways, it says, in a home industry, the total cost in rand of producing X number of cakes per day is this. So before we even carry on reading some more, in the industry, right, they said here the total cost in rands of producing a certain amount of cakes per day is this amount. So this is R amount, you see. So meaning depending on what the number of X is, it's going to give us the total in rands that is going to be made. Now, this is clearly the other thing is, before we even carry on reading this question, the one thing we want to take note of is how this is actually a quadratic equation. It's a quadratic equation that actually has a smiling graph. So if you think of it nicely, this graph would, this image here, or this equation would draw an image something like that. Now, this is already something you want to be thinking of to say that, okay, clearly we can see that the more cakes you're going to make, right? Initially, you're going to start by somewhat making a loss. This is clearly what this is saying. You're not going to be, the number of rands you'll be making, they're just getting lower and lower and lower. But let's not say you're making a loss. Let's just say according to our, because of how this behaves, we know that the total cost of producing cakes, right? If you're going to make a certain amount of cakes, the more you make, the cost of making those cakes gets like lower and lower and lower until a certain point, and then the price of making those cakes starts getting higher. That's exactly what this is saying, right? They say that the total cost of producing X number of cakes per day is this much. Now here they're saying the price at which they are sold is this much. Now we can clearly see that the price at which they are sold is also based on the number of cakes that they make. So we can see that without overthinking it also, you want to remember that this is literally going to draw a straight line graph, you see. So if you look at it nicely, this equation in standard form would look something like this, and then plus the 50 there, you see. Now, in a straight line like this one, right, you know that it would draw an equation that looks like that. And then this would clearly be telling you that the more cakes you're going to be making, the lower you're going to be charging for those cakes, you see. And then we can see that here, this is already telling us that there's a certain amount of cakes that we can make until we almost cannot charge anything for them. This is just one of those things where we don't want to overthink it yet, but then this is some of the things that should keep our brains turning to say, okay, this is just a parabola. This is just a straight line graph. Even though we're talking about some home industry and some cakes, whatever, and runs, it doesn't matter. The properties of what we see here will always still stand, you see. So with all that being said, they say it here now for 10.1, show that the profit made is given by this formula. So in the beginning, we said, whatever you read, we want to think of a real life scenario, and we want to think of how, the real world works. And we know that when it comes to profit, it's all about, okay, what you spend to like make that thing, and then how much do you sell it, and then you compare, between the two. So if let's say spend, let's say 20 rand making it, but you sell it for 30, then we know that the profit is 10, you see. So that's just the basics of what we know, right? So that's exactly the same way we should be thinking here. We should be thinking to ourselves, okay, fine, we're going to make a certain amount of cakes. It's going to cost us this much, depending on what X is. And then we're going to sell at this specific price, right? This is going to be the price of each of them. So the issue here is we don't know how many we're going to sell, but it doesn't matter. All we need to know is, okay, fine, this is the cost of making the stuff. And then we know that this is what what you call, this is what we're selling it for, you see. So based on what we had drawn here, right, your profit will always come out from what you sold it for minus what it cost you, you see. So if you sold it for 30 and it cost you 20 to make, your profit is going to be this 10 here. So as long as we understand this analogy, we can then use it for what we have here, right? We can literally just say, okay, fine, this is what we're going to sell each of them, and this is what it cost us, you see. So our profit here, based on the equations we're dealing with, our profit is just going to be what we sell it for, which is technically 50 minus half x. Just make this a bit bigger there. 50 minus a half x, right? There we go. This is what you sell it for minus the cost. The cost is like 1/4 x squared. And then that's like plus 35x. Then this is like plus 25, like that. So if we simplify nicely, we should just expect to get something like this. So already here we're getting some negative values. So that's promising. So let's see, a negative this cubed. No, squared. The scary thing though is let's see here. This is what? Negative 3/4 squared minus the 15, and then what should I call here? Minus 25. Well, I think I'm getting a bit carried away here because it actually just seems a bit too easy to be true, or a bit too good to be true actually. But then let's see. Let me see here, because negative 3/4. Where would we be getting the negative 3/4 now? Show that the profit made is given by this formula. So we know that this is what you sell each of them. Wait a minute. This is what you sell each of them, yes. But then the amount that let me put it this way. If each of them is like 50 Rand, right? And you sell 10, you technically make 500, correct?
Yes.
However, if you do make 10, the cost of you making it is just going to be this value here times 10, right?
Yes.
Oh no, I mean wherever x is would put a 10, because this is saying in the home industry, the total cost in Rand of producing X number of cakes per day is this much. So X is the number of cakes produced, meaning that if you're selling each of them for 50 Rand, right, you know that the amount you're going to be getting is 50 Rand times X, because X is how many you're making. 50 is how much you're selling each of them. So the amount you're making times the price is actually what your total money is, correct? Yeah. So that's what we need to be careful of here. So this price here, right, we do have to multiply it with what is this? Let me just get my calculator also, so that we can, this price here, we have to multiply it with X, because this is saying that, okay, this is for one of them, but then we are saying that whatever one costs, the amount we're going to make is just this amount multiplied by X, because X is how many of them we actually sell. So the amount we sell multiplied by the price, this is the money we make, and then we're subtracting how much it costs us to make all these cakes. So the reason why I paused here is because based on what we're trying to get, right, there was no ways we were going to end up with like negative 3/4 there. So that was automatically a red flag. Hence why, you know, going back to the question and going back to the description is helpful, because whatever you think the first time, I mean, you can always change it as you answer your question.
Yeah.
So here, if you multiply inside, this is like 50 times the X, and then minus 1/2 X squared, right? And then you're gonna have here minus 1/4 X squared, and then minus 35X, and then minus 25, see? And then what now? So we're gonna have here, let's see, 50X minus 35X, or rather, let me see, these two here, we can work with that first. This is where the negative for x squared is coming from. And then we have here negative 35 plus the 50. Let's see if we're, yep, it's adding up. So this is like 15x. And then there is the negative 25 that we have at the back there, negative 25. So it's a 2-mark question. However, I think this is a good example of how whatever questions we get, we just need to put ourselves in that exact scenario, which is where, again, the whole, if we have 50 cakes and we make, if we have 10 cakes and we sell for 10, we're actually making 100. We're actually making 500. It helps with getting this figure, because the amount that is sold is not just the price, it's the price multiplied by how many we sold. But then it doesn't matter, this still stands, right? And then here we have it. So that's for 10.1. 10.2 is a 3-mark question. What do they say there? It's saying they calculate the daily output of cakes to obtain maximum profit. So this is a very, very direct question that has a very specific way to answer it, which is very similar to all the other questions in your applications of calculus that have this word in them. Anytime you see this word, always focus on, firstly, getting an equation of what they're talking about. So whatever they're talking about here, they're talking about profit. Secondly, we have an equation of profit. That's good. As long as you have an equation of what they're talking about, that's like 1 foot in the door. So this question is, you calculate the daily output of cakes to obtain maximum profit. So daily output of cakes. So daily output of cakes. So when we hear the words daily output of cakes, they're talking about x, because x is the number of cakes per day, you see. So when they speak of daily output of cakes, calculate the daily output of cakes, they're asking for a value of x to obtain maximum profit. So to link this up with, functions and graphs and calculus and all that, what we know is, since they're talking about profit, what you want to think to yourself is, okay, fine, we have a profit equation. Now, this profit equation, remember, you always want to look at it in a very literal sense. When I say you want to look at it in a literal sense, I mean that the kind of equation we have here for P is, it's a parabola. The fortunate thing is you can see it's a frowning parabola. Now, because we know it's a frowning parabola, we do also can see that, okay, wait a minute, this graph does have a maximum value that it goes to, you see. So even though they're talking about maximum profit, as long as this is a parabola, we know that they are just talking about the turning point, because the turning point is where you have the maximum value in this equation. What we can already see is, depending on what the value of x is, as x increases, right, your profit will be increasing until a certain value. And then once you keep increasing x, your profits start decreasing. That's exactly what this equation is trying to tell us. Hence why this question is asking us for the maximum profit, because this question is showing us that there's a certain value of x that allows us to have the highest profit. The moment we pass that x value, we're going to have lower profit. The moment we think of an x value before that, we're going to have lower profit. So we need to have that sweet spot. So without even being too crazy about it, the fortunate thing is, anytime you need to work out the maximum of something and you have its equation, always take its equation. So this equation is in terms of x, right? So what you want to do is, in this equation, right, it's our profit equation. We basically need to work out the turning point, of which whenever we need to get a turning point, we always differentiate once and we make the equation equal to 0. So we do that because every time when we differentiate once, we're basically getting the gradient equation of the graph. And the gradient equation, in it, right, we can basically look for where the gradient is a 0. Because wherever the gradient is a 0, that's where we have the maximum value. So that's why we make the first derivative equal to 0, because we will be saying, if the gradient is a 0, where do we find that x value? Of which the x value where the gradient is a 0 is going to be the x value where we have the highest profit possible. So let's differentiate once here. Differentiating once is this times this, which is like negative 6/4. 1 times 15, it's like positive 15. And then here we have x to the power of 0, and then here it's a constant, so it falls away. So making this equal to 0 now, we have negative 6 over 4x plus 15. This can go to the other side, and then you can have here divided by 6 over 4 divided by 6 over 4, like that, you see. So with that being said, here you're going to have x, and then what? So here you can have this over this. 15 over this number here. Where did I put the calculator? Did I even get it? I was trying to look for my calculator, but I don't know what happened. Oh, I finally got it. So the 15 over the 6 over 4 there. So it's 15 divided by 6 over 4. That's giving us a 10. X value is a 10. Yeah, perfect. So what this is saying is the daily output of cakes to obtain the maximum profit is 10 cakes. If you want to have maximum profit, you just need to make 10 cakes. If you make less than 10 cakes, you're going to have less profit. If you're going to make more than 10, you're also going to have less profit. 10 is like the sweet spot. Now, obviously, since this is a parabola, another way we could have done it is we could have said x is equal to minus b over 2a, because it's still a parabola. And this only works for a parabola if you need to get the turning point of a parabola. Meaning we would have said negative 15 over 2 multiplied by a, right? Which is like negative 3 over 4 there. If you put everything in the calculator here, let's see. Negative 15 with 2 and negative 3 over 4, close bracket, we're also still getting a 10. So two different methods that get the exact same thing. Because remember, this literally comes from differentiating and making your equation equal to 0. But it was introduced in grade 11, so they didn't show differentiation. Because if you have a quadratic equation like this, right? If you differentiate it to get dy over dx, what you're going to have is 2 times a, which is like 2ax, and then 1 times the b is like a b. If you make it equal to a 0, you're going to have 2ax here plus b. If you solve for x now, the b is going to go over, and then you have like 2ax. And then if you divide both sides by 2a, you can see the x is going to be on its own. And then you have minus b over 2a, you see. So it's not to say that one method is more superior. It's literally the same thing. One is a shortcut, but it only works for a parabola. If it was not a parabola, we know this won't work, you see, because you're not differentiating something like this. So that's one thing to keep in mind when we work with a parabola. It has special privileges. But anyways, with the next one here, show that the cost of baking is a minimum at x is equal to 10. So this is clearly, you can see this is clearly one of those really weird questions that may make your head go, wait, what? Did we not just answer this question? So it's like super common, of which it's a 5-mark question also. And I mean, like, quite frankly, the way it's written out, it's not the kind of a question where we're gonna read it and we're gonna be like, oh, that's what we must do. Nope. It's the kind of question we're literally reading and we're going, wait. But then what's the difference between the two questions, you see? So it's quite a strange question. But then you see with this question here, the previous one, it was focusing on maximum profit. So if you look at the difference between 10.2 and 10.3, remember we said whatever you do, always when I was drawing this out, I said here we need the maximum profit. So we need to work with the profit equation. Here we need to show that the cost of baking is a minimum where x is a 10. So technically what we need to do is we need to have an equation for the cost of baking and then work out where it is a minimum. You see? So we had this, we're just going to be working with a different equation. And the equation we're going to be working with is the cost of, making these cakes, of which they told us here we have an equation for that. You see, in a home industry, the total cost of producing, so you see that's where the baking is. The cost of baking X number of cakes per day is this. So when they're speaking of cost of baking, we have a new equation we're dealing with, you see. So the cost, let's just write C maybe. Let's just say here C with X here. This is equal to a quarter, X squared plus 35, X plus 25. Now, logically speaking, you can see this is all making sense because they're asking for a minimum value because they know that this sketch draws a smiling parabola. And it's only a smiling parabola that has a minimum value. See, they could not have asked for a minimum value here because it's a frowning parabola. It has a maximum value. So here, this one has a minimum value, see, which it's still going to be a turning point. So it's like the same questions twice, or the same question twice. Two birds with one stone. You're not going to do anything different. So for us to show that the cost of baking is a minimum at X is equal to 10, let's just differentiate and equate to 0 and see if we're also going to get a 10 here. If we don't, then we have to reassess our steps and see if we made any mistake. But well, let's see. Let's differentiate once. So differentiating once, we're going to have 2 times a quarter, which is like 2 over 4. And then 1 times 35 is like 35. And then x to the power of 1 minus 1. 1 minus 1 is a 0, so x to the power of 0 is a 1. Fine. Now, when you differentiate a constant, it just falls away. So this we said you should make it equal to a 0, right? So this is equal to a 0. This is like half x plus 35. It doesn't look like it. It doesn't look like it's working out, but let's see. Let's just carry on and head bomb out with class. So let's see the next one. What is the next one? Let's see. This is gonna go to the left. We have negative 35, a half x, and then if you divide both sides by what you may call a negative. Oh, wait a minute. Actually, now that I think of it, I mean, what you may call show that the cost of baking is a minimum at x is equal to 10. Okay, so we're saying this is not working, man. We're saying this is not working. But if you read the question again, show that the cost of baking is a minimum at x is equal to 10. So what we do know is that, let's read the question again. So if you see what we're doing, right, whatever error we're bumping into, or whatever, whenever the question seems like it's a bit strange, it's a bit difficult, it's like not happening. The only thing you really have is the description, because the more you're gonna go back to the description, there are certain things that they're almost like they are just subtle. You know, when you look at it once, you may not see it. When you look at it again, you may not see it. But then when you see like, okay, it's not working out. Yeah, usually, you know, things start to happen. So let's see here. They say in an industry, the total cost in rands of producing producing X number of cakes per day is that in rands. So that's the cost, right? And then they say the price at which they are sold is this much. Well, I had it. I don't know why I said or, but I think my subconscious has maybe thought of something, because yeah, it's really not. Let me see if we didn't cut out anything. Nope, we didn't cut out anything. We copied the what you may call the entire question the way it is. So let me just go back. ISO, go back. So the one thing that I'm thinking of now is we have the cost of like everything. Remember this is, oh yeah, you know what, this formula we're using, there's nothing wrong with it. This is wrong. This may not be working out, yes. But then the one thing we can be rest assured is that we're not dealing with the wrong formula, because this is asking for the cost of baking. Now, this is the only cost equation we have. But then if they're saying show that the cost of baking is a minimum at x is equal to 10. So remember, let's think of this logically now. This is where our logical thinking cap has to come into play. Logically speaking, I mean, whether we like it or not, right? It says the cost of whatever is given by this, Now, do you see that this takes into account everything that you're going to be baking? There is not, this is not to say this is for one cake. You see that this is for everything. regardless of how many you're going to make. So if you think of it logically, the cost of baking, to show that is a minimum, to show that the cost of baking is a minimum at excuse me, at 10, what we need to think of is how this is for all the cakes. However, if you think of it nicely, the cost of baking one cake is technically this amount divided by X. You see, because if you bake 10 cakes and this is the cost, it means that the cost of baking one is going to be this amount divided by 10. So let's say you baked and your cost is like 500, and you baked 10 of them. You see, if you want to find out how much each of them cost, it would be 500 divided by 10, which would give you like 50. You see, this would tell you, okay, one cost 50 Rand to make. So this is the analogy we need to use. We need to keep in mind that this is more like the 500. This is the cost of everything. But then the cost of like one cake is going to be this amount divided by X, because X is the amount of cakes that we make. And then this is how much it costs to make all of them. So if they're saying here, we should show that the cost of baking is a minimum at X is equal to 10. Technically speaking, the cost of baking is this amount divided by X. This amount that they gave us, it's the total cost. You see the difference? Cost, total cost. So the total cost they gave us, right? But then the cost of each is just going to be the total divided by how many we are dealing with. So it's such a subtle way of wording it. This is still a cost equation, but it's the total cost. We need the cost of like one item, you know, one or cake. So this is saying the cost of baking is a minimum where X is equal to 10. So instead of us using the total cost formula, we're just going to use a formula that just has one cake into consideration. So here we can see that this is just going to be a quarter X squared divided by X, right? So we might as well even write it out, you know, just for the vibes. Here we're going to have 35X over X. Here we're going to have 25 over X. And then we can clearly see that 1X cancels 1X. We're going to have a quarter X there. And then here, X over X, that's going to be 35. And then here now we have to take the X upwards so that we are able to differentiate. Taking it upwards, we're going to have something like this. Now, this is still your, what you call your cost equation. You see, it's not the total cost equation, it's the cost equation, because the cost equation is the one where you're dividing by the number of cakes that you would be making. So this is technically giving us the cost of one cake, but they want us to show that the cost of baking is at a minimum where X is a 10. So it's almost like saying they are trying to make us sure that the cost of baking one cake, the lowest possible it can ever be, is like if X is a 10 or something. But then without overthinking it, I think we broke through when we changed the cost equation with the total cost equation to just cost, meaning instead of worrying about all of them, we're worrying about one now. So because they spoke about a minimum of some sort, we would also need to keep in mind the same analogy. You see, this is still, okay, no, hold on. We would need to keep in mind the same analogy. Now, because this one, we could easily draw a parabola. It was all nice and dandy. But then logically speaking, this one, you see, even with the negative X here, it's kind of difficult to predict what image this looks like. But this is where your differential calculus comes into play, because your differential calculus allows you not to worry too much about all that, because your differential calculus is the one that reminds you that, okay, as long as you're seeing these words here, minimum or maximum, whatever you do, have an equation of what they're talking about, and then take that equation, differentiate it once. So differentiating this equation once, it's going to be 1 times a quarter. There is like a quarter. Then 1 minus 1 is a 0, and then x power of 0 is a 1. This is a constant, so if you differentiate it, it falls away. Here you can have negative 25x, and then minus 1 is going to be like minus 2. So you have a differentiated equation, and based on what you know that you just differentiate and you make your equation equal to a 0. You see, so making this equal to a 0, we're solving for x now. So solving for x, this can go over. It's like 25x negative 2, and then this is like a quarter. Since we're trying to solve for x, you really don't have to overthink it here. You can just divide by 25 here, divide by 25. In the calculator, let's see, a quarter divided by 25. Yo, it's going to be quite interesting. It's going to be quite a small number, I guess. Quarter divided by 25. This is like 1 over 100. So if you look at it nicely, here you can actually just use your calculator, actually. Because in your calculator, you can put a square root symbol with like a -2 there. And then you do the same on the other side. -2 there. So this is going to cancel that. In your calculator is going to give you the answer here. So let's do it. Shift the square root symbol, replace the tiny 3 with a -2. And then we have like 1 over 100. Whew, that looks very good. We're getting a 10. Yeah. So again, we didn't overthink it. Maybe we did for a bit, but then the only thing we did was going back to the question, as we said we should. There's nothing else we can do. We cannot manufacture anything. Here we had clearly a profit question, a profit equation nicely. But then here now, this is total cost. So I think that's where the whole 5 marks really comes from, because yeah, realizing that this is total cost, but then this is asking about the cost. Yeah, it's shady, but it is what it is. It's gonna, you can imagine how going through a few questions that look something like this, it's gonna stick that, okay, wait, the wording is important, because depending on how they word the questions, it's going to give us an idea of like how we should answer the questions. So that was that for that one specifically. Let me just remove this ISO.